In this lesson, we're going to be discussing even, odd, and neither function. Functions can be classified as even, odd, or neither function based on how they behave when the input is replaced with its negative. That is when you compare f of x and f of negative x. Now let's talk about even functions. Now for even functions, f of negative x must equal f of x for every x in the domain. And then graphically, the even functions are symmetric about the y-axis. For example, let's illustrate it with the graph of y equals to x squared, which is the parent function of quadratic function. So this is positive y, this is positive x. So we're just going to keep it this way. So the graph goes like this. So if you look at this graph, you see that this right hand side is a mirror image of this left hand side. Again, to confirm it, if you fold this graph along the y-axis, you see that this part and this part are going to join together. All right. So that's how to know the graph of an even function. It is symmetrical about the y-axis. The right hand side is the mirror image of the left hand side, and the left hand side is the mirror image of right hand side, just vice versa. So examples of even functions. For example, we have f of x is equals to x squared. F of x is equals to cos x. F of x is equals to the absolute value of x. Now, the graph of this cos x is given as, this is just a sketch, right? So this is how the graph of the cosine function looks. So if you take a good look at this sketch, you see that this side of this graph is a mirror image of this part of this graph. So it is symmetrical about the y-axis. All right. Also, the graph of the absolute value function is like this. That's the parent function of absolute value function, looks this way. So if you look at this, you see that this right hand side is a mirror image of this left hand side. Also, if you fold this graph, this part and this part are going to join together. So that's how to know the graph that is an even function. So let's just solve few examples on this even function. Now, for example, if you're given f of x is equals to x raised to the power 4 minus 3x squared, and wants to determine if this function is even. So as we know that for even function, f of negative x is equals to f of x. So we're going to replace all the x's here with negative x. So we have that f of negative x is equals to, we have negative x raised to the power 4 minus 3 into negative x raised to the power 2. So this is equals to, now negative x raised to the power 4 is going to return x raised to the power 4, because negative times negative times negative times negative will give you plus. All right. So we have minus 3 multiplied by negative x raised to the power 2, which is negative x times negative x, is equals to x squared. So this becomes x raised to the power 4 minus 3x squared. So we have that f of negative x is equals to this. Then if you look at this answer, you see that this expression here, x raised to the power 4 minus 3x squared, is equals to f of x, which is x raised to the power 4 minus 3x squared. So since f of negative x is equals to f of x, we now say that this function is an even function. So let's solve one more example. If you have f of x is equals to x raised to the power 6 minus x squared. So let's find the f of negative x. So this is going to be negative x raised to the power 6 minus negative x raised to the power 2. So f of negative x is equals to negative x raised to the power 6 is going to be equals to x raised to the power 6. So far the exponent here is even number, is going to return a positive value here. So I have minus, now negative x squared is equals to x squared. So you can see that f of negative x is equals to f of x, because this expression here is the same as this function that we asked to determine if is an even function. So this is how to determine an even function by calculation. So let's discuss odd function. Now for odd function, f of negative x is equals to negative f of x. Alright. So for example, if you have f of x is equals to s cubed minus x, let's determine if this function is odd function. So we're going to replace x with negative x. So I have f of negative x is equals to, we have negative x raised to power 3 minus negative x. So equals to negative x raised to power 3 is equals to negative x raised to power 3. When you have an odd exponent, negative number raised to power an odd exponent is going to give you that negative number, right? So minus times minus will give us plus x. But since we have negative number in front of this function, let's factor out negative 1 in this function. So I have equals to negative, then we have x raised to power 3 minus x, right? Because minus times minus is plus, minus times plus here is minus. So we have that f of negative x is equals to negative x raised to power 3 minus x. Then I have that f of negative x is equals to minus, then this is f of x, so which satisfy the condition of an odd function. So as you can see, this here is equals to this, alright? So this function here, x cubed minus x, is an odd function. Let's solve one more example. We have f of x equal to x raised to power 7 minus x raised to power 5. So we have that f of negative x is equals to, let's replace this x with negative x. I have negative x raised to power 7 minus negative x raised to power 5. So f of negative x is equals to, so far the exponent here is 7, is an odd number. We are just going to repeat this negative x. So I have negative x, then minus this one again is odd power. So let's just replace it with negative x raised to power 5. So this is equals to negative x, sorry, this is 7. Then minus times minus is plus x raised to power 5, alright? We have f of negative x here. So f of negative x is equals to, let's factor out negative sign here because of this negative in front of this function. So we have negative into, let's just change the signs. We have x raised to power 7, then minus x raised to power 5. So if you look at this, you see that this expression here is equals to this. Then let me just finish it up. F of negative x is equals to negative, now this is f of x, which satisfy the condition of a function being an odd function. So let's go ahead and discuss neither function. Now for neither function, I have that f of negative x is not equals to f of x or negative f of x. So this happens when the function has mixed powers, that's mixed even and odd powers. For example, if you have f of x is equals to x raised to power 2 minus x, as you can see, this is an even power. This is raised to power 1, which is an odd power. Anytime an expression or a function has mixed powers, then that is mixed even or odd powers, then it's going to be another function. But let's go ahead and prove it. You have f of negative x as equals to, we have negative x squared minus negative x. So this will give us x squared, minus times minus is plus x. So this is f of negative x is equals to this. Now we have x squared plus x here, and our main function is x squared minus x, right? If you try and factor out negative here, you're going to have negative x squared minus x, which still didn't give us the original function. So we say that this function is a neither function. So anytime you have an expression or a function with mixed exponents, that is, some are even and some are odd, just keep in mind that that function is a neither function. So let me give you tips on how to identify even, odd, and neither functions. So we have even function here, then odd function, and then neither functions. Now for even functions, all parts of x are even. Alright, for example, 2, 4, 6, then and so on. Then for odd functions, all parts of x are odd. For example, 1, 3, 5, and so on. And then for neither functions, is a mixture of even and odd powers usually. And then for another point here for even function is that it is symmetric about the y-axis. So it's symmetrical about the y-axis. And then for odd functions, they are symmetric about the origin. So odd functions are symmetric about the origin. So let me explain this origin, like being symmetric about the origin. So let's take this function as an example. Y is equals to x cubed. So this function is the parent function of cubic equation or cubic function. So the graph of this, just a sketch, looks like this, right? So the graph looks like this. So as you can see, this part of this graph is equals to this part of this graph, right? So this part and this part are the same. So we say that they are symmetric about the origin. Or if you flip this graph or rotate it to 180 degrees, you are going to get the exact shape of this graph. So that's how to identify a graph that is an odd function. Now for neither functions, the graph will not be either symmetric about the origin or symmetric about the y-axis. So this is the end of this video. Thank you for watching. Remember to subscribe to my YouTube channel, turn on the post notification bell so that anytime I post a new video, you're going to be the first to watch it. Also don't forget to like, comment, and share with your friends. Thank you for watching.